Dear students, how are you? I hope you're fine. Today we're going to have a new lesson. It's about vectors. So, when we talk about a vector, it here determines the direction and the speed of an object. Okay, guys? So, you have here, you can here say that the vector is the quantity that has both what, this is important here. Vector has quantity that determine the length and the direction. The length and the direction, we can say, instead of the length, we can say the magnitude. So let's start. You can think that of a vector as a directed line segment, a directed with a direction line segment. Okay, so the vector below here may be named as AB vector, and this is what, and this is the sign of the vector. Okay, it's like the arrow, as you see, or we can say V, okay, for the vector, and here this sign. We have here an initial point and a terminal point, an initial point and a terminal point. The initial point we start with, and the terminal point we end, that has no end in the arrow, as you see. The vector can also be named using what, using the component form. What are the component form you got here? We have here the x and y. So, of a vector, let's the horizontal and the horizontal and the vertical change from the initial point to the terminal point. See how can we we have here the component form, as you see here, CD vector, as you see here the CD vector, this one. So the we've got here some components. So we got here, as you see here, this point from starting point, the starting point, as you said, the initial point. Here we moved how many points? 1, 2. So we got here 2, we got here 2, and then we go up until what? 1, 2, then 3. So the components here we got 2 and 3. So we put it in the 2 here, signs like this. Okay, write the vector in component form if of hg. So this is very easy now. Okay, I moved here to the left, so negative 1, 2, 3. So we have here 3, negative 3, and up 1, 2, 3, 4, 5, positive 5. So we have here negative 3 and positive 5, the components of the hg vector. Easy one, I think it is. What about this? Write the vector in component form. Okay, mn with m negative 8 and 1, and n 2 and negative 7. Okay guys, here we have what? Okay guys, here we have write the vector in component form, and he gives you here the components of m and the components of n. So we got here what? We got here the initials and the terminal points. So my rule here is very important. Subtract the initials from the coordinate of the initial from the coordinates of the terminal. So I'm going to memorize this very well. X sub 2 minus x sub 1. This is x sub 2 minus x sub 1. 2 minus negative 8. Then I have here another one, and this will give me the component of the first here initial. And we got here what? We got here negative 7, the sub 2, y sub 2 minus y sub 1, negative 7 minus 1 gives me negative 8. So, and this is mn vector components. Very easy, very easy. Okay guys, we have here the magnitude. What's the magnitude? It's the same as the length of a vector is its length. Okay guys, so when we say the length, so the magnitude of a vector is written as what? As you see here. Okay, this one. Okay guys, or by using v. Okay, the absolute value, because it's a length. Okay, when a vector is used to represent speed in a given direction, the magnitude of the vector equals the speed. Okay guys, so for example, a vector represents the course of kayaker paddles. the magnitude of the vector is the character's speed. This is okay, good information we got here. Let's go to the questions and how can we solve problems here. Draw the vector -1 with components -1 and 5 on a coordinate plane, and then find its magnitude to the nearest tenth. Okay guys, step 1, this okay, this is will be taken also next year inshallah. So but we are gonna have a quick quick overview over it. Okay, draw the vector on a coordinate plane, use the origin at the initial point. So we are using the initial here, as you see, 0 and 0. Use the origin in the initial point, then -1 and 5. -1, guys, -1 go like this here, and then 5 go up. So this is here the terminal point. This is my terminal point, -1 and 5. Okay, okay. Then find the magnitude. The magnitude here, guys, using the distance formula. So I have here negative, this is the terminal and this is the initial 0. Okay, the initial, and the initial is for the origin. So we put here our, as you see, our initial point on the origin. You know the origin 0 and 0. And we have got here the terminal point -1 and 5. Then using the distance formula here and substituting here the distance formula, you got here the magnitude or the length of the vector. So the distance, I wrote here the distance formula to make sure that you memorize this: x sub 2 minus x sub 1 minus y sub 2 plus y sub 2 minus y sub 1, all here squared under the square root. Remember that we have taken this on quarter 1. So remember here we have x here, we have here x sub 1 x sub 1 and y sub 1, 0 and 0, this one, and we've got here -1 and 5. By substituting in the rule, -1 minus 0, okay, all to the power 2 plus 5 here minus what? 5 minus 0, all to the power 2. And then after that, after taking this and 26 under square root, gives you 5.1. Gives you 5.1. Okay, guys, this is easy. I think it is. Okay guys, so when we talk about the vectors, so we have got a direction for the vector is the angle. What's the direction of the vector? It's the angle here. Okay, formed from the horizontal line, and what? And the vector. So we got here, this is measured, this measure is the measure of the here the angle is measured counterclockwise, this direction, like this, counterclockwise. Okay, from the positive x-axis, from the positive what, guys? From the positive x-axis, this will be 60 degrees. Have another question here. The force exerted by Skyer is given by the vector. We have here the components 1 and 4. Okay guys, let this be the, yes, excellent, this is the terminal, this is the terminal point, and let the initial point be the origin. So the origin here 0 and 0, the terminal point is 1 and 4, so 1 and 4, so this one. Okay guys, then find the direction of the vector. He asks me to draw the vector on the coordinate plane, and this is very easy. The origin here is the initial point, and here the terminal point, it's 1 and 4, the component of 1 and 4, 1 and 4. Okay guys, then draw here the arrow, as you see, and we have got here the vector. After drawing the vector on the coordinate plane, this is the first step. Use the origin as I told you. Okay, find the direction here. How can I find the direction? Very interesting here. So focus, you will love it. So I have here to draw a line to complete here the triangle ABC. Okay guys, I draw here a line B connecting B and C. So we have got here, he asks me what? He asks me here, find the direction. Remember the direction in the previous slide here, what's the direction? The angle here, the angle formed here on what? On x-axis, okay guys, counterwise, remember? Yes, this is angle A. He asks me for angle A. How can I find angle A? This is very easy. I need here angle A. Okay guys, okay, so remember I have here what? I can get here this side. Yes, the length of this side. Yes, 1 2 3, 1 2 3 4. So we've got here 4, right? Okay, and what else we've got here? So who remembers this? When I want this one, tangent of angle A equal opposite over adjacent, remember? So tangent of angle A equals opposite here is 4, as I told you, 1 2 3 4. At the adjacent, this one, this side, the adjacent is 1, so 4 over 1. So I need here the tangent or the inverse, because I need the angle. So here angle, measure of angle A equal tangent, okay, tangent power -1 on the calculator by shift tangent -1, the inverse function, okay, here of 4 over 1. So I have here the degree is 76 degree. Okay guys, let's have another question here. The force exerted by a tugboat is given by the vector 7 and 3. So he asks me to draw the vector on the coordinate plane, find the direction of the vector to the nearest degree. Okay guys, I have here, I will start drawing here the initial with in the origin 0 and 0, and you've got here the other one, it's the terminal point, so you have 7 and 3, 7 and 3, so move here 7, 1 2 3 4 5 6 and 7, 3 up 1 2 3. Okay, after drawing here this point and this point, this is the arrow, okay, the arrow, and then you got here this line to close the triangle. Find the direction. So I need to find the direction now. This is the angle that's here, counterwise angle. Move the counterwise, counterclockwise, and it will be angle A. So as the last one, tangent of angle A will be the opposite over the opposite here over the adjacent. Opposite here 1 2 3, so we got here 3 over what? 1 2 3 4 5 6 7, 3 over 7, tangent of angle A. So we need the angle A, so I will say angle A equal the inverse of tangent, okay, 3 over 7, so we got here 23 degree. Okay guys, so here we have another kind of vectors. When we, or another partition here, we're going to talk about two vectors are equal vectors if they have the same what? The same length. The same length mean the same magnitude and the same direction. So if they have the same length and the same direction, so they are what? They are equal vectors. Okay guys, equal vectors do not have to have the same initial and the terminal point. They don't have to have the same initial and the terminal point. Maybe they are different, but they have the same length and the same direction, so they are equal. And this is very, we have here another here character for the vectors. We have parallel vectors. They don't have to have the same direction. They may have the opposite directions, and they may have different magnitudes, although they are here what? They are parallel vectors. Here I have identified the following equal vectors, where here the equal vectors. So we have here ij, as you see ij, this one, and what? OP and OP. They are equal because they have what? The same magnitude. It means the same here length, 1, okay, 1, 2, and 3. And here 1, 2, and 3. And they have the same direction. So they are equal. So they are equal. Parallel vectors, we have here ij and OP. Where's ij, guys? Ij and OP. They are parallel. Oh yes, they are parallel and they are equal. What about KL? KL and NM, they are parallel, even that they have opposite directions, but they are parallel. I hope you understood the lesson. If you have any question, please send me on the new system. If you have anything to, okay, don't forget to answer the Google form.